Hello, my name is Hasan Emre Çamur. I'm a first year electrical and electronics engineering student in Bilkent University. In this video, I will present my Physics 101 laboratory project, which name is Friction's Effects on Angles of Equal Range in Projectile Motion. The main purpose of my experiment is to study the effects of friction on the angles that result in the same range in projectile motion. Firstly, I needed some data to draw the graphs that I will use to make the comparisons. So I have launched projectiles at 8 different angles and 3 throws for each angle to minimize the error rate of my experiment. I have recorded the ranges in a table and made additional throws for the angles that gave more inconsistent ranges to minimize the error. Because the projectile didn't stay in the launching position in the smaller angles, most of the additional throws was made on the smaller angles. After that, I have measured every parameter that this experiment has made on to calculate the ranges in a frictionless environment. The rest of this research was calculations. I have calculated the ranges in a frictionless environment using Python and drew the graphs using MATLAB. Function used to calculate the best curves in this experiment is called polyfit, which uses a method called second-degree polynomial least squares regression. After drawing the graphs and appreciating the way I have gotten so far, I have calculated the necessary values that will be used in the comparison process, which are both of the angles that result in the ranges 1.4, 1.6 and 1.8 meters, and the vertex point of both of the graphs. It's good to mention here that angle 1 is the smaller angle and angle 2 is the bigger one in these tables. Then came the comparison process. I have checked error percentage first and found an expected increase of energy lost as the angle rises. The more interesting part came when I compared the angles that resulted in the set range. First thing I have noticed was that the angle difference to get a certain range was smaller when the angle was higher. This is probably because friction affects the object in both waves in the vertical direction, countering its effects on the range, which is not the case for the horizontal direction. So as angle gets bigger, the horizontal speed lessens and the vertical one increases, lessening the effect on the range. The second thing I noticed was how distances between the angles and the vertices was nearly the same in the experimental throws. In a normal case, we would expect the calculated ones to be the same, but in this experiment, because we had a starting height at the start, it has changed the angle points, which turned out to be a lucky height, which breaks the equality in the calculated throws and establishing equality on the experimental ones.